Hello everyone, and welcome back to Math. Hope you're all having a wonderful day, and I got one scrumptious sode for you prepared. So today we're going to be looking at a neat application of prime factorization. But when people first learn about greatest common factors, which is what GCF stands for, they don't necessarily think that it actually ties into prime factorization, but I'm going to show you that it very much does. So let's start with looking at what does a GCF mean. So GCF is short for the greatest common factor. And sometimes that is also written as like HCF for highest common factor or something like that. There's some variations of it, but we're going to go with GCF here. That's what I did when I was in school. And what does it mean to have the greatest common factor? Well, what it's going to be is we're going to have two different numbers, and the greatest common factor is the factor that is common to them that is the biggest. So for example, if I took the numbers 8 and I took the number 12 and I listed their factors, we see that 1, 2, and 4 are all the common factors here. And 4 is the biggest of that group, so that means the greatest common factor of 8 and 12, which is often written like this, where we have GCF and then parentheses, and then 8 and 12 are like our inputs into this GCF. And that is going to be 4, because that, out of all the common factors between these, 4 is the biggest. So it's a pretty simple idea, right? So maybe as another example, find the greatest common factor of, let's say, 30 and 45. We could go ahead and list the factors of these numbers. So for 30, we got 1 and 30, 2 and 15, 3 and 10, 5 and 6. And then for 45, we have 1 and 45, 3 and 15, 5 and 9. Alright, so you can go ahead and check if these are all the factors of these. And if we look for the greatest common factors, so let's first circle all the common factors. So 1 and 3 are, and as well as 5, and so is 15. So 15 is the biggest out of all those common factors. So that means the greatest common factor of 30 and 45 is 15. It's a really easy concept, right? It's pretty much just a little bit of extra stuff based on an already familiar idea of finding the factors. But now what I'm going to do is I'm going to add a layer of hidden depth to this that I think is really quite nice. So we saw that in the previous video, we can, in order to find the factors of a number, it was sufficient to take the prime factorization of that number and then look at all the different combinations of those prime factors. And then that would give us every single one of these factors. So for example, with 30, we can prime factorize that. So 30 is 5 times 6. So 5 is a prime we chunked off. And 6 is 2 times 3. Both of those are primes. So we know that 30 is 2 times 3 times 5. And then with 45, we know 45 is 9 times 5. 5 is a prime. And then 9, that is 3 times 3. Both of those are primes, so 45 is 3 times 3 times 5, or 3 squared times 5. So then using these, we could get all the possible pairs of 2, 3, 5 to get all our factors of 30. So we have 2, we have 3, we have 5, we have 2 and 3, we have 2 and 5, we have 3 and 5, and then we have 2 and 3 and 5. And this gave us 2, 3, 5, 6, 10, 15, and 30, which is exactly all of our factors here. Of course, we have to add 1. And then over here with 45, we have to do, so we have a 3 as an option, we have 5 as an option, we have the combo of 3 and 3, we have the combo of 3 and 5, and we have the combo of 3 and 3 and 5. So that gives us 3, 5, 3 times 3 is 9, 3 times 5 is 15, and then 45 is this product right here. So this is just review from last video. If you're unsure about that, please go and watch it. But the point is with the prime factorizations, we can also get all of our factors of the number. So since the greatest common factor is a factor of the number, we should be able to actually use the prime factorizations of these numbers to figure out what the greatest common factor is going to be. So for example, we know that 3 is a common factor with these, since 3 shows up in the prime factorization, right? Since 3 is in the prime factorization, 3 has to be a common factor for both of these. However, we also see that since 3 and 5, right, this pair here shows up in the factorization, then that pair of 3 and 5 also has to be a common factor, right, since this pair is common to both of them. And so we get 3 times 5, or 15, is a common factor, and indeed that's true. And this is all the commonalities of prime factors between 30 and 45, right? This 3, 5, and this 3, 5. So basically what we want to do to find the greatest common factor is to find all the common prime factors of the two numbers, and then that is going to basically be your biggest combination of primes, which will then give you a factor based on it being kind of listed in this in these groups of prime numbers down here, and that is going to be your greatest common factor. So let's do another one to kind of emphasize what I just talked about here. So let's find the greatest common factor of 24 and 36. All right, so I'm not going to find all the factors of these. I want to try and use this prime factorization method I was just talking about. So let's first of all prime factorize these. So 24, that's 2 times 12, so there's a prime number. 12, that's 2 times 6, so that's a prime. And then 6, that's 2 times 3. Those are both primes, so we get that 24 is 2 times 2 times 2 times 3, or 2 cubed times 3. And for 36, all right, we can split off this into 6 times 6. And each of these 6s we can split off into 2 and 3, and those are primes. So we get that 36 is 2 times 2 times 3 times 3, which is 2 squared times 3 squared. So now what we want to do is we want to basically circle all the common prime factors. So the common prime factors are, we have a 2 and a 2, we have another 2 and another 2, and then there's a 2 here but not another 2 here, so we can't circle that one. But we are going to get a 3 and a 3. So basically these are all the common prime factors between 24 and 36. So then what we do is we take those, so 2, 2, and 3, multiply it out, and that gives us 12. And since this combination was in both of these, we know that 12 is going to be a factor of both 24 and 36. And furthermore, since there is no larger combination of these, right, if we try and include the 2, there's no 2 over here. If we try and include this 3, there's no 3 over here. So since that's the largest possible combination of our prime factors, then we see that this has to be the greatest common factor. So we get then that the greatest common factor of 24 and 36 has to be 12. All right, let's try one more. But I think you're kind of getting the idea at this point. Basically, we're able to use what we did in the last video about knowing that every single factor can be determined by the prime factors in order to determine a special type of factor, namely the greatest common factor. So let's go with find the greatest common factor of, let's maybe do some bigger numbers. Let's go with like 102 and 34. All right, so let's try this, 102 and 34. So we'll prime factorize 102. Let's see what we get. Well, we get 102, that's even, so we can split that up into 2 and 51. 2 is prime. 51, it kind of looks prime, but if we add up the digits, 5 plus 1 is 6, we see that's going to be a multiple of 3. So 51 we can split up into 3 and 17. You can go ahead and check that. We know 3 is prime, we know 17 is prime, so 102 is 2 times 3 times 17. Awesome. Now let's try 34. So 34 I can split up into 2 and 17. And would you look at that, we're already done. That was a nice quick prime factorization. So now all we have to do is basically just find all the common prime factors. So this one we have 2 is in the commonality and 17 is. This has a 3, but that 3 is not present over here. So that means then that 102 and 34 have 2 times 17 as a shared factor, and 2 times 17 is 34 itself. So that means 34 is basically the common factor of 102 and 34. Now, in this case, since 34 is the largest factor, and 34 is actually one of the numbers we started with, what this actually tells us is that 34 itself is a factor of 102. We see this because this 2 and the 17 in the prime factorization of 102 will give us 34 as a factor. So we actually see that since 34 is a factor of 102, the greatest common factor is just going to be 34 itself. So this has been a trend with the last few videos, but it's going to be a shorter lesson today. I hope you found this interesting though, and if you maybe knew the idea of greatest common factor before, did you know how to find it by using the prime factorization, or did you have to write out all the factors every single time? This is a nice quick method to do it, and yeah, prime numbers, man, it's the gift that doesn't stop on giving. So I hope you enjoyed, but that's going to be it for me today. Have a good one, stay groovy, and I'll see you in that next video.